Good morning, ladies and gentlemen. My name is Godfrey Bridger. I am an advisor to the Institute of Public Works Engineering Australasia for the Street Lighting and Smart Controls program, about which we are going to talk today. My first duty is to thank the Australian Government's Department of Environment and Energy, their E3 program, which is the Equipment Energy Efficiency program, without whose support this webinar would not be possible. A couple of minor housekeeping things. Could you edit your name, please, as shown on the slide at the moment? At the top item on the menu is a way to edit your name, to put the name, organisation and state, or if you're coming from out of Australia, please put the country that you're coming from. And when you have any questions, please submit them by the chat and direct them to the whole audience with a tab. The webinar is going to be in 10-minute segments, approximately 10 minutes. The first one will be a little bit longer with questions and answers for each, if there are any, of course. Otherwise, we'll have them at the end. The webinar will describe the street lighting and smart controls program, the roadmap, the website and the conference, and webinars, which we'll tell you about. So, to come to the roadmap, this was published in mid-December 2016, which is virtually like the beginning of 2017, because Australia and New Zealand go on holiday from that point onwards. It can be downloaded for free on the website shown there, and it looks like that. I'd like to strongly acknowledge the council members. There are two two categories of members in the SLSC program, and that is the council members shown here with their logos, who have put significant effort and investment in, and TAG members, the Technical Advisory Group, who have also put important effort in and can be seen on that list there. Just to give a quick introduction to the Institute of Public Works Engineering, for those of you who don't know, they have about 4,000 members across Australia and New Zealand, and they come from the important public works engineering areas of asset management and management in areas such as roads, water, power, rail, ports and airports, and of course, in this case, street lighting, which was started a couple of years ago. I'll mention later. The Street Lighting and Smart Controls program was put together as a public-private partnership for all of us to get together and facilitate the upgrade of street lighting to LED and controls, and to accelerate it. The roadmap that was put together, which is discussed today, was to do exactly that, but in a documentary form, so it was on record and provided a lot of information detail, which you'll hear a bit more about. And the authorship of the roadmap was my two colleagues, Brian King and Graham Moore, and myself. So what are we going to talk about? Why light the streets? Why use LED and controls, LEDs and controls? What will it cost? Why isn't everyone converting now? That question follows logically from the previous three, because the argument is so compelling to do so quickly. How can the risks be reduced? Everything has risks, and how, in fact, the answer to that is by using the SLSC program. And again, I'll be covering that in some further detail. A quick summary of what I'm going to tell you is basically why do it? Because streetlights can save more than 30% of injuries and fatalities at night. Investing in street lighting is one of the most cost-effective investments of safety you can for dollars per injury or fatality saved. While you're doing an upgrade to LEDs, which we're suggesting one does, of course, you can address some of the gaps in Australia's and New Zealand's darker roads that they have in the world. Basically, we have the lowest lighting levels in the in the OECD countries. And of course, by doing so and addressing all of this at the same time as putting in the LEDs and controls, you can actually save significant amount of money with a net present value. So let's go on to discuss exactly how this is the case. Firstly, this graph shows the proportion, I emphasize proportion, of the population of each of the countries listed that have died as a result of road injuries or interpersonal violence in grey and road injuries in blue. And Australia's on the far left, and you can see that it is one of the middle of the pack, except that the upper part of the pack are not so good. Clearly, the rest of the world has got some very high levels of injuries occurring, fatalities occurring due to road, and America and New Zealand are beating Australia, and Canada are beating Australia. All the rest of our sort of OECD peers are below Australia. So we cannot sit on our laurels. And the issue that we're addressing here is called street lighting. And what we want to know is what effect can street lighting have on these rather numbers that are we can't be so proud of. So if you look at the next graph here, which comes from, by the way, down here there'll be a number, and that number is the page number on which the graphs come from. If you see this graph, this is the proportion of fatal crashes occurring during night time, and this is in Australia. And you can see that across the years, the percentage is around about 40 to 45%, which is a large proportion given that very small parts people do not travel that much at night time. Most travel occurs during the day. So clearly, nighttime injuries and accidents are an important contributor of our poor statistics. This slide, shown on page 9, shows the relative level of illumination on required by our standards. Australia and New Zealand standard number 1158 identifies the levels of lighting required on our roads at night, according to the different types of roads. V1 to V5 are main roads in black, and you can see there are lit to about 75% or less of what Europe requires. If they were lit the same as Europe, there would be a bar showing 100%. In the case of residential roads, it's significantly worse, and you can see the lighting levels are dramatically below what they are in Europe. So one has to wonder whether injuries could be reduced by increasing lighting levels. There is a huge body of science, more so in street lighting than almost any other area of transport, that shows lighting has illuminating the roads, unsurprisingly, reduces accidents. But there is real science to show this. And there's a variety, and that table there comes from the 2016 Norwegian edition. It was translated by us by one of the co-authors, Dr. Rune Elvik, whose name is on the second 2008 edition of the Handbook of Road Safety Measures. In English. This one's in English, and most of us use it. Rune Elvik is there. He is coming to the conference we have on road lighting in Brisbane next month. So he'll be having to say a few more things that I'll be drawing attention to on here. This graph is a scientific, it shows the scientific results by Jackler and Frith in 2012 that relates to the lighting levels. So here's lighting levels going across the bottom of the graph, the x coordinate of the graph, and the vertical coordinate basically shows the number of accidents. It's the day to night ratio, so that it's actually more accurate than just saying whether it's the night accidents. But basically it shows the reduction, the increase in lighting levels reduces accident and injuries. Here's another graph that's on page 11 of the roadmap, and it shows back in 1999 some research that showed the reaction time is reduced for white light than it is for yellow and orange lights. And in those days we didn't have LEDs, which are white basically, and LEDs obviously will behave in the positive way that mercury metal halide did back in those days. This big gap of reaction time at about 400 milliseconds, which is a long time, and of course translates to many meters of travel at 50 or 100 kilometers an hour. In our residential areas, this reaction time reduces as the lighting intensity increases. It reduces to 0 difference between the two colors at 3 lux, so 3 candela per square meter. Sorry. So the point being here that these are the V categories which we have in our main roads, but here in our residential areas we're very sensitive to what color the road lighting is. Back to Dr. Rune Elvik, who I mentioned was the editor of the Handbook on Road Safety. He is a scientist at the Road Transport, the Transport Economics Institute of Oslo in Norway, and he has put together the research that shows that road lighting has benefit cost ratios that are very high depending on the annual average daily traffic flow. So this is traffic flow, and from the point of not much above 0, over here you can see the benefit cost rate is 1, which is basically when the cost of the measure, i.e. putting in road lighting, equals the payback. And very soon after very low levels of traffic flow, you can see the benefit cost ratios are huge. If this were an investment, you'd be accused of trying to run a scam, because 10 times return on investment is totally unheard of. But that corresponds to about 30,000 vehicles annual average daily traffic, and you will see that on the next screen on a picture of Austroads annual AADT levels in Adelaide, and you can see there are several at that higher level on that graph. So quite clearly, road lighting is a very, very important fact. I would argue an under-recognized fact of transport planning, or an under-recognized tool of transport planning. Finally, we come to a negative aspect of street lighting, because there are negatives. Like everything in life, there are positives and negatives, and they've got to be traded off and managed so that the best outcome is received by our society. And in this case, it's a common picture that shows the heavy lighting levels coming from that are being wasted. This is light that's being wasted. It's not being used. It's going up into space. Australia and New Zealand look quite low level by comparison, but in fact, what's more important than the absolute levels is the level compared to the population density. And on that level, Australia is not doing that well. These are the best at the top, and the worst are at the bottom. And you can see that Australia is not so good. And at that point, we'll stop for questions and come back to the next section, next segment. No questions, so we will go straight on with discussing why LEDs. Now, I'm not going to cover too much time on why LEDs, because most people now know that they represent the future of most lighting applications. But very quickly, they use 50% or more or less of electricity for the same amount of light output. They last 4 times longer or more. They can be minutely controlled in tiny steps from 0 to 100%. There's no mercury. They are vibration resistant because they are a hardware type of product. They're highly directional and efficient, so they actually focus the light in very, very specific places, much more so than any of the previous technologies. They have several shades of light cut possible depending on your use, and they are instantly on or off. So they are really more akin to computers than they are to traditional lights. This is a slide shown in page 33 of the roadmap, which originally came out of the Practice Note 11 put out by IPUIA in 2014, which basically shows the nomenclature used in road lighting. Luminaire represents the whole light and its enclosure and the fixture and the glass and the lens. Corresponding to that, the LED is actually a much simpler device and has far less gaps and cavities involved. The light source is where the biggest difference occurs. Here, the light source in the traditional technology has high voltages, high pressure gases, high temperature filaments, whereas over here it is absolutely a totally encapsulated hardware device. And over here we have power supplies that look very much the same for LED technology between the old technology. In fact, they're quite different because these power supplies generate high voltages, and whereas these generate low voltages and therefore are safer and have a whole lot of other benefits. As mentioned before, this grouping of technology is closer to an iPhone or a computer than anything else, certainly closer to being a computer than that is completely different. The physics are completely different. So it is a step change that we are looking at. One of the big things to reduce your electricity use by 50%, the efficiency has to be amazingly better than the current technologies. And this shows a graph of back to 1879 through to 2000 to the present, basically. 1879 is where the light bulb, or the incandescent light bulb, was invented, and you can see here it's not changed much. Oh, I forgot to mention that this, of course, the vertical coordinate is the critical one, which is the amount of light measured in lumens. That's the physical quantity of light per power or electricity used. And so clearly you can see that over the years, the 100 years from or more, there's been a general increase in performance of these lighting technologies. But when you compare to what happened to LEDs have just, been originally developed back here and shot through there. Another important aspect of lighting is its color, because as I've already mentioned, its color has an effect on the reaction times, but it also has an effect on human beings' ability to assess color or process images. A person seen in high pressure sodium with yellow light is much more difficult to recognize because you can't pick up all the different colors in their skin color tones or their clothes, whereas LEDs and mercury vapor, who have much whiter colors, you can. So that's an important factor. The next question that I mentioned earlier was why we want controls, why would we want such things in our cities? Basically, they will bring about a revolution that is often quoted as being smart cities, but this actually also applies to smart towns and smart rural areas. How is that? Well, in Europe, they call it the humble lamppost. And the reason for this is that lamppost for a long time has been ignored, and now it's coming into its own. It's no more humble. In fact, not only does it have LED lighting and control systems that I'll mention do wonderful things for street lighting, but it is a magnificent infrastructure foundation for a whole lot of things. You can see the electronic signs here, but it also has the ability to have image sensing, CCTVs for security or parking, concealed speakers, a microphone to tell if a woman is screaming because she's been assaulted, or if shots are going off. And these are real applications being constructed worldwide. Not in large quantities at this stage, but it's absolutely clear that the future holds this. And another obvious application is to have these lights using electricity at night. Well, during the day, why not use them to charge electric bikes or vehicles? And of course, there are a whole lot of sensors that you can apply. So this, including parking and so on and so forth, and here is a water flooding or even fire in more remote areas, they can alert early warning for fires. So all of these things are absolutely vital, and the big issue for city planners and infrastructure constructors is not to overlook these benefits that are coming down the track very quickly, just like electronics came quickly, the internet came quickly. These things are coming down the track very quickly. Street lighting is infrastructure or thousands of points for every city, town, or village even, perhaps not thousands for a village, but the point I'm making is that you don't want to visit these things very much. You want to, if you're going to replace them with LEDs, install them in a way that future-proofs controls, because you're only going to be visiting street lights seldom. You don't want to visit them a lot because they're expensive to visit. So those were what I would call the more glossy applications for smart cities, but there are very, very solid engineering and asset management reasons. This Cisco table, which is in page 39 of the roadmap, shows a list of the old approach to lighting, and it's very old and totally outdated now. We can remotely monitor these lights that, like anything, eventually fail, but before they do, can give you plenty of warning, and you can gather 10 or 20 or 30 of them together to visit 10 or 20, 30 times to fix. So you can do smart asset management. You don't have to wait till they fail. It's pointless to wait to let them fail, because if you get them before that, you can put them together with 20 others and make one visit instead of 10 visits. Smart dimming and scene setting is a clear obvious. You don't need lighting 12 hours a night. Only the busy times is where you need lighting, or where the dangerous times, or whatever the community determines, but you certainly don't need it 100% of the night. And of course, the thing that always surprises me is that most street lighting in the world has never been metered. So these things are calculated. They're based on estimation on inventories that quickly lose accuracy, but now you're able to measure the electricity use that each single light uses, if you wanted to know that. In fact, it's gathered that way, and then it's all agglomerated together. Now, it's important to note that controls are often considered in Australia and New Zealand and America, less so America, but our controls are considered as a luxury, too expensive, not needed. In fact, compare that approach with the United Kingdom, which in 2012 had many more controls in its street lighting than Australia and New Zealand had. And Australia and New Zealand had zero then, and basically almost have zero, not quite, now. In 2016, almost more than a third of all street lights in United Kingdom are controlled by controls. So this is a really important trend, which we believe makes sense for all street lighting to have. One of the interesting facts that comes out of Europe in comparison to Australia is there they have 60 to 90 million lights, and in Australia you have 2.4 million. The proportion of streetlights over 25 years old in Europe is 75%. That's huge. We think that it could easily be the same here. We don't know. But when you put that together with the fact that you're going to save a lot, that you're going to save electricity and you're going to save lives and greenhouse gases, it just makes it's a no-brainer really to address this issue properly. The roadmap contains quite a lot of information about controls to assist councils and distributed network service providers for that. It's not the mandate for this webinar to go into that sort of detail, and we move on, but just to say that it's there. There is one rather large effect that's sweeping the world, and that is solar photovoltaic generation of electricity. And there are several manufacturers making streetlights with these. And here's one in Denmark that is a very expensive one because they've made it very stylistic and wrapped the solar PV around the power pole and put a wind turbine on the top. So it makes it basically self-sufficient and batteries inside. A cheaper version of that is shown here with a very simple panel that picks the light up, stores it in the battery, and uses the electricity at night. So those issues, that of course saves the reticulation, the cost of reticulating those power poles. If they're already reticulated with power, it's probably not as economic to do this. But if you're putting new poles in with lights, then it could well be. So now we move on to what will it cost. And in order to determine what it would cost, you have to, of course, know, what it will cost to replace LEDs and controls. You have to know what's out there at the moment. And to do that, it's covered in Chapter 6 on page 47. This is a quick summary, and we sent out a survey to all the 15 distributed network service providers, otherwise also known as electricity utility companies, or actually it's electricity distribution utilities. So they're the ones that own the cables and the wires, not the generators. And there are 15 of them across the states of Australia, as you can see here. And really the interesting points shown here is that LEDs have penetrated around about 10% in New South Wales and about 20% in Victoria, but not much elsewhere. A check was done at the same time to check to cross-check, really. We wanted several sources of information. So we also surveyed suppliers and asked the suppliers confidentially what they had provided and accumulated their figures into this table here on page 54, which shows you that they had supplied 107,885 LED P category luminaires and 2,000 V category to the DNSP, so the electricity distribution network service providers. So, and then councils were these, and so on and so forth. The numbers between what the supplier said and what the DNSP's electricity utilities have said were different, but we believe can be relatively easily explained. They were only 30,000 different out of 2.4 million, so that's a pretty small proportion, and we're pretty happy with the figures that we obtained from the two surveys. Back to the streetlights, according to the electricity utilities, here is a breakdown of each of the states, with mercury vapor the least efficient lighting technology available to the world at the moment, and in fact clearly being wound down. There's 39% of Australia's stock is that very old technology, about 50 years old. The high pressure sodium, arguably 30 years or 40 years, between 35 years old technology, there are 31% of Australia's stock is theirs. Only 6% are LED. It's important to understand, if we are doing a strategic plan and everyone is wanting to make plans and policies, one has to know according to not just the states, but according to the type of roads. And so we've done that, shown in page 50. The table is broken down of the different categories on the different types of roads. Finally, the estimated cost of running those streetlights, the current stock of streetlights, what had to be calculated so that you could calculate the savings when the new one went in the LEDs and control. And so for comparing against a future replacement, the current stock of Australian streetlights, according to our calculations, is costing Australia 423 million per year, averaged across the 15-year life. And that's what we mean when we say levelized. We calculate it because it's not a square, it's not a rectangle, simple. It's actually, it actually increases to the end, but the end is actually, of course, less expensive because it's in future dollars rather than present dollars. So that's all been averaged out, and we've made it simple by calling it $423 million a year. So the benefits of changing to LED street lighting and smart controls are, as summarized in page 56, 52% energy saving and 52% greenhouse gas savings with installation of LEDs. Of course, that does not mean an automatic 52% reduction in costs of electricity, because that's not the way that the electricity is charged simply. However, energy savings of another 10 or 20% can be added to that if you use smart controls. But in discussing the actual cost reduction summary, that's not been included in this 25% reduction in total cost of public lighting, does not include the smart controls, because the smart controls also means additional expenditure. But what also is not included in that 25% is that we have safer roads, we have potential crime reduction, we have environmental gains where no mercury, and we have this big leap in capability to have smart cities, towns, and rural areas and their livability. So those are not factored in with these hard numbers. The hard numbers that would come by, the estimated capital cost of replacing LEDs in a large-scale way is about $1.1 billion. savings of $180 million a year based on 15 cents per kilowatt hour. There is an estimated maintenance saving of $60 million a year, and based on a 50% reduction, which is pretty conservative, and simple payback of 4.5 years and a present value. So these are magnificent figures, and they exclude control systems. So why isn't everyone doing it now, converting now? And the answer is for many reasons. There are many reasons tabulated in the chapter 11 that I just showed, and this extract comes from there. It's not the place to be going into these in the webinar, but it's certainly fully covered in the roadmap. We also discuss stakeholders, because all public organizations that serve the public need to be very close and understand their stakeholders. In fact, this program, in my view, would be a dream one to manage with stakeholders, because the messages are so positive everywhere if you include all the issues we've identified in the roadmap, which includes, by the way, putting control systems in to mitigate against the negative aspects of street lighting, or white street lighting, I should say, mitigate against the negative effects of white street lighting. What messages can you use to your stakeholders? Well, we have a table there on page 92 that lists them all out for you. And what risks do you face when you convert over? There were two types of risks that we discuss in chapter 13 on page 93. That was one of them, the risks that you face in converting over. But there is also a risk that the Street Lighting and Smart Controls program has, because after all, this is required investment by the government and the private sector. So these have risks as well, and they are identified in chapter 3. So finally, just to remind you, why convert to LED and controls? Because not only will you gain significant sums of money, save significant sums of money from LEDs and controls, but in the process, if you reassess your needs and match them to the requirements, and match match the investment to your real needs, and reassess the situation, you might also increase the number of decrease the number of injuries and fatalities at night, and knowing that the investment that you make is one of the best you can available. And by using controls, you can offset the negative aspects of street lighting, which is, the white lighting effects. White lighting clearly reduces transport injuries and accidents, but at the same time, it's not good for people who want to sleep, or insects, or birds, or animals who want to live correctly, nor is it ideal for a dark sky. So controls can have an impact. And finally, one of the positive reasons for converting is because you probably have the best program in the world to help you do it. Street lighting and smart controls, after many years of being in this area, we believe we've got one of the best programs that basically covers everything that one could in this area. So just to recap now a little bit on the Street Lighting and Smart Controls program itself. It started towards more sustainable street lighting, and Practice Note 11 in 2014. I put this together. Again, my colleagues Brian King, Graham Moore, and myself worked on this with a lot of consultative input, of course, from everyone in Australia, and which is the same as the roadmap. The SLSC program can be summarized on you can see here, the roadmap was put together at the end of last year. The council meetings occur every quarter. The down here we have a website that was put together and has been published, and I'll show you, a little later. We have model control specifications, which also have a little slide later coming very shortly. I've only got about 4 more slides to go. And the webinar series, this is the first. That square represents the one we're just giving right now. It's actually a month early, which is good. And here is the conference next month on the 14th of March. In the roadmap, in page 70, in that area of the roadmap provides all the content of what the SLSC program is about, and 2 of these things are happening very shortly. The model LED lighting specification is being put together, and the next webinar after this one will be on that subject. And after that, the model smart control specification will have a webinar about a week later, I think. To mention the SLSC website can be seen here, slsc.org.au, and that is the front page. And as you can see, the top just is showing the free industry webinars, or first, which is this one. The conference can be seen in that website, and it is on the 14th and 17th of March, and we hope you'll all be there. The webinars already discussed. April the 4th is on the model LED specification, presented by Graham Moore, and on April the 11th, presented by Brian King, we'll have the model smart control specifications. And once again, to thank the council members that have made this possible, as well as, of course, the E3 program from the Australian Government's Energy and Environment, Department of Energy and Environment. And finally, to remind you, the conference is on 14th and 17th of March at the Brisbane Exhibition and Convention Centre, and you can register at that place. So finally, at this point, I can say thank you very much again to the E3 program of the Department of Environment and Energy. If you would like to ask me anything about what I've just been presenting, those are my details there. And if you want to find out about the Street Lighting and Smart Controls program, please contact Nicole Patton at Equia Australasia. Thank you very much. So, Graham, I think you are still switched on, are you not?
Hello, can I be heard? This is Kudus Wazizada. I have a question.
Yes, go ahead, Kudus.
Okay, thank you. Yeah, very enlightening presentation, and I've gone through this document. It's very comprehensive. IPWA has been in this field for quite some time, and this have been providing us a lot of literature to think about. The only thing I see here as a problem is that the largest ownership of street lights is with DNSPs, and they are in no hurry to change. They're probably going towards change, but they are not in a hurry to change. And I know you would understand what I mean by that, because the actual users of lighting are the councils and the road authorities, but we have limited sort of leverage in changing lights to more efficient ones and with smart controls, because the owners are DNSPs and they are going about it in a very slow manner.
Yes, Kudos, a very highly valid point, and one we clearly identify in the roadmap. And we are, of course, involved with discussions with both the ENA, Electricity Networks Australia, and of course the Department of Environment and Energy, who are aware of this. So I think it's very much in a situation where the past has, we're all get very, very used to doing the status quo, and let's face it, electricity networks are very much about reliability, long-term, looking to the head to reliability, and is not well known, and we don't want it to be a dynamic, full-speed industry. So it's been a difficult issue for them to resolve, and I think IPUIA has a very important role to help in that, and hopefully that can progress. I'm not sure if it doesn't really answer your question, because it's not a question that anyone can answer at the moment. It really needs to be answered, I think, by the federal government in line with the distribution network business.
Exactly, and that is something we all sort of eager to and keen to find out what role the federal government is playing and how they will facilitate everyone to change to the more energy efficient.
Kudus, you haven't mentioned for everyone to know that, of course, you're from the Roads and Marine from New South Wales.
Maritime Services, yes.
Maritime Services, sorry, yes. Yeah, so in charge of all the roading of the state roading.
That's right.
So have we got any other questions from anyone else? You have to turn if you want to ask a question, you have to turn your speakers on, your microphones on.
Godfrey, there's a question from Ed at Actu-AGL, and maybe he'd like to turn his microphone and ask that.
Okay, Ed, are you on?
Yes, can you hear okay?
Yes.
Can you hear me? Okay. It was just a question about, you mentioned that we had the darkest roads in the assessments that you did. I was just wondering if that comparison was made on the basis of where streetlights were deployed, because obviously otherwise it means that if we had to deploy more streetlights, then the savings that you're talking about we wouldn't be able to achieve.
Yes, very, very good point, of course. Look, this is not about, first of all, the graph I showed was a graph of the standards comparison, the comparison between the European standards and the Australian and New Zealand standards. So that's what it shows. It doesn't show actually what the street lights are doing on the road. But your point is a vital one, because quite clearly some roads do not need the high levels that one might, or we maybe put a different way, some roads we cannot afford to light as strongly as we would like. And so we are not suggesting at this stage any particular strong change, but what we are strongly suggesting is a close look at them. When you're doing an upgrade in your LED lighting, you should strongly consider putting controls in, and strongly consider, are they the right lighting levels? That's what we're suggesting.
Yeah, great. Thanks for that. And I do think it's a great report. Thanks.
Great. Thank you. Anyone else like to ask a question? Paul Samaratunga. Would you like to, you have the microphone if you want to speak.
Yes, my question was, if you go down the path of using the street lighting for controls, are we locking ourselves out for future enhancements, especially for smart city initiatives?
So that's another very good question, and I think the simple answer to that is no, if you do it the right way. And unfortunately, control systems are not simple. And so that's the first unfortunate thing. The second unfortunate thing is they're brand new, so they haven't been around for many years. But we do have quite a bit of precedence over in Britain and other parts of the world, not in Australasia, but in other parts of the world. So I still think the answer is yes, you can proceed at the same time as being future-proofed. A very simple example, a very, very simple example, is by putting in the NEMA socket, which is a standard socket, 7-pin socket that allows digital signals to be put in and out as well as power. And that is a good illustrative example of how you can future-proof. And that particular socket only, even if you don't want to run something immediately, that particular socket only costs $5 or $10, and you can put that in lighting. But it's a bit more complex than that.
Thank you. I asked that question because I understand that Melbourne City Council and Adelaide City Councils have gone down the path of trying or piloting other scenarios other than using street lights. That was the basis of my question.
Right. Thank you, Paul. We've got another.
Thank you.
You're welcome. Thank you.
Godfrey?
Yes.
Godfrey, this is Behram Pistanji from the Roads and Maritime Services. More than a question, I just want to make a statement, and probably might be an encouragement for others. We have a smart lighting control already in the offering, and LED conversions are happening as a matter of policy for those lightings which have reached the end of life. And this is something that we can do at our end. Now, however, the smart controls, what you mentioned, thank you for reinforcing our belief that the smart controls in whatever technology which are available to us today are going to be a benefit for the energy saving, especially in the road lighting arena. For us, the tunnel lighting had smart for quite a while, and learning on that, we are extending that to the open road lighting also. So I just wanted to share that with all the participants. Thank you.
Thank you very much. Could you repeat where you came from and your name again, please? I didn't catch it very well.
Okay, it is Behram Pistanji from the Roads and Maritime Services.
Oh, right.
Of New South Wales.
New South Wales, right. So how many control systems have you got installed?
Well, we have the first one under trial, and we have something close to around 8 or 9 tunnel control systems operative.
Okay, but how many lighting points?
We have the first one around the figure of around 25 to 30 at the moment.
Okay.
Which is smarts. Yes.
Yeah, no, that's fine. No, thank you for that. Thank you. It's very interesting because it's really useful for these sort of sessions to share so that other people are aware of what other people are doing. Still a way behind, of course, other parts of the world, but absolutely not surprisingly, we're making fast forward.
We certainly are, but we need to be cautious in terms of some of the questions that came earlier. It does make sense to be cautious and have it future-proof.
Yes. Would anyone else like to comment? I see CJ Neo on board. Would you like to comment on what's happening in Singapore?
Sorry, just got in. I will chat with you in a short while. Let me tidy up my stuff first.
Okay, no problem.
Okay, so sorry.
No problem. No problem. Any other questions or from anyone else? So I think we've. Robert, do you want to say goodbye at all? I think we've covered to the end of our 45 minutes, well and truly. And I hope it's been useful. I think the feedback has been good. And remind you that the conference on next month, 14th to the 17th.
Yeah.
Yes. Who's that? Someone wanting to talk? I think not. I'm going to mute you all to say goodbye. And so to remind you once again that the conference is available. Oh, what's happened to PowerPoint? Where is it?
Lost the screen.
Yeah, there we are. So the conference is on 14th and 17th of March. Come along, and webinars next April the 4th and April the 11th. So see you all there. And there's my contact details if you want.
Definitely. Yeah, thank you very much.
You're very welcome. Bye-bye.
Thank you, Godfrey. Thank you everyone for attending.
Okay.